It's topic 1, and we are going to cover scientific notation, which mainly involves moving of the decimal point. Scientific notation is a really important topic in science, of, and it's very important in math, physics, uh, biology, chemistry, in most of the sciences. So, generally speaking, scientific notation allows us to describe a very large or very small numbers. It just you applying really simple notation. So notation, this notation is going to look like this. We are going to start with a number. Make sure this number is non-zero number. So let's say this is going to be a non-zero number. Then it definitely should be dot. And then you can write as many numbers as you wish. You can put one number or two, three or four. It's up to you. So I'm going to put dot dot dot, but you can put many numbers times 10 to some kind of exponent. So let's see. The majority of the problems will involve very large numbers, just like I said before, or very small numbers. So just to begin with, we can start talking about some kind of big number. Anytime you're talking about big number, you can think of millions, billions. For example, you can think about number of molecules in some kind of compound. For example, you can ask how many molecules in water. I mean, how many molecules in one drop of water? And then you can definitely understand there are a lot of molecules. There are a lot of this really negligibly small particles. So example of such a number could be something like this. Let's say 1 500 000. Let's do, yeah, that's good enough. This is a very large number. Uh, so just to work on this number, all you need to understand, anytime you see big number, you should use, so first of all, you should move decimal to the left. This is solid rule number 1. And final rule is that you must use positive exponent always. So anytime you confused, you really need to come back. So see the stand, and it says there is exponent place. You should, for big numbers, you should use positive exponent. Also, what's important to understand is that you would always need to find first and second number, and we go from left to right. So like in this case, it's going to be 1 and 5. And first number can never be zero number, so it must be non-zero number. So in this case, so see this as box, non-zero box is a point, and there is a number. So in this case, it's going to be 1.5. So non-zero number, point in between, and 5 is just the next number. You can put as many zeros as you want. This topic will be significant figures, but this topic will come in later videos. For now, we got 1.5 times, then we use 10, and now, just like it says to use positive exponent and move decimal point to the left. So basically, at this point, the question is where do we have decimal point? After this big number, decimal point comes after less 0. So right now, all we need to do is just figure out how many places we must move this decimal point. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is where we stop. So we put point between 1 and 5. We moved 9 places. You can say 9 units. So this is our exponent. This is our 9. Make sure to use positive because this is a big number. So you use positive 9. Don't try to put negative 9 or anything like that. So it should be positive 9. So let's talk about similar case, but this time it's going to be some kind of small number. And usually small number we refer to the number which is greater than 0, even though it might be less than 0, but it should be extremely small. It should be between 0 and 1, so it should be as close to 0 as possible. So example of such a number could be, let's say, 0.000, 5 more zeros, 70. So definitely you can see this number is very small. So for example, this number could be described, for example, you have an atom and you want to find out the radius of this atom. So for example, obviously the radius, let's say we're talking about centimeters. So this number could represent, this number could be represented 10 centimeters, which is, I mean, overall this value is really small, and you can say that some kind of atom has this kind of radius, and you can see the number is very small, very close to 0. So just to understand what's going on and how to convert this number to scientific notation, so what we are going to do is, so notice for big number, we move decimal point to the left. In this case, we move decimal point to the right. To the right. So this is something you should memorize. And eventually you will just understand it, because the more practice you do, the better you just become at it. So we move point to the right, and also we must be using negative exponent. And this is the way we symbolize small numbers. So let's see the way it's going to work. So again, we should put a dot between first and second number. First number should be non-zero number. So let's say between 7 and 0, this is 7 is non-zero number, and 0 is going to be 0. Second number doesn't matter. It can be 0 or any number. So we are going to start by writing 7.0 times 10. Notice that we must use negative exponent just because it's a small number. So we put negative sign, and then again we move decimal point to the right. So we just count how many places the actual dot is moved. So we take 1, 2, 3, 4, 5, 6, 7, 8, 9. So we notice that we moved it just 9 times. So you put negative 9. So if you, whether you say this long method or just 7.0 times 10 to the negative 9, it makes things much simplified. So obviously instead of working on such big numbers, it's much easier to work on smaller simplified version of the same kind of representation of the same number. Alright, so next example could be just trying to understand how to make a backward conversion. So for example, notice that so far we converted a number to scientific notation. So it was a number to scientific notation. Right now what we are trying to do, we are trying to take scientific notation and convert to a number. Just a number, not really a scientific notation number. So just there is main rules that you have to follow all the time. That say when we go from number to scientific notation, we move decimal to the left. Right now we'll be moving the same decimal but to the right. Just opposite when you go back. Because what essentially you're doing is you're multiplying. You make number larger, you make it bigger. So that's the whole idea of making big value. And so let's try to do some example. Let's say we got 9.0 times 10 to the 2. So it says 10 to the 2, so it says that we take 9.0, so we take this dot between 9 and 0, and we are going to move it in new location. We're going to move it 2 units to the right. So it's sort of, you take 9 times 100 should give us large number, 900. So we take this dot and we move two, two places to the right. So instead of 9.0, it actually becomes 900. And this is going to be result for this problem, 900. So, but when you work on smaller numbers, what should be done is you have to, so for small numbers, notice when you went from a number to scientific notation, let me just select it as a table. So we move decimal to the right, but right now what we are going to do, we are going to move decimal to the left. So we are going to make number smaller. Or alternatively, we divide. Okay, so for example could include something like, let's say, 8.1 times 10 to the negative 3. So what we are going to do in this case, we are going to take 8.1. There is a dot between 8 and 1, but right now we're making it be smaller. We, just because of this negative, we actually dividing it. So we are going to move this dot 3 times to the left. So all you need to do is just you put 0, 0. This is the new location of the dot, and you put 0 in front of it. So you got 0.0081. So notice the number got smaller, which actually makes sense because we divided it. So those are general rules that we'll be using constantly from now on.